Sir, I'm starting, sir.
Fine, sir. Yeah.
Okay. Good evening, all of you. This is Dr. K. Kiran Kumar, Vice Principal and Head of the Department of Computer Science and Engineering. On behalf of Chalapati Institute of Engineering and Technology, Department of Computer Science and Engineering, I welcome you all for the workshop on ArcGIS Developer Workshop Part 2. There are a total of 4,626 participants registered for this workshop from 23 states in India. I thank all the participants who have registered for this workshop. Today we have four resource persons, Mr. Yuktesh, Subham Singh, Yashi Agarwal, and Sarthak Bhatia. Thank you, sir and madam, all the four resource persons for accepting our request and coming as resource persons for this workshop. Let me introduce about the college. So CIET was established in the year 2007 under the leadership of Sri Y.V. Anjal Garu, former MLA in AP Legislative Assembly. The college was located in the capital region of Andhra Pradesh, Amravati. Ours is an autonomous college under Acharya Nagarjuna University, accredited by NBA, NAC with A grade, and UGC 2F. We offer both UG and PG courses as well. Coming to the Department of Computer Science and Engineering was accredited by NBA. It is a very active department in the college. We have conducted more than 50 events in the pandemic period, which includes FDPs, workshops, webinars, HTTPs, seminars, etc. Till now, more than 25,000 faculty and students got benefited from the events which we have conducted since May 2020. So let me introduce today's resource person, C. Yuktesh Garu, Manager Relations, ESRI India Private Limited. He is having 12 plus years of industry experience, and from almost last 10 years, our organization is associated with him. He helped us driving many student initiatives, and he is also a board member of our college and also various colleges located in and around South region. And he is also helped us in developing our curriculum for the BTech. So I thank C.H. Yuktesh Garu for accepting our request and conducting this workshop. Thank you so much, sir. Yuktesh, sir. This is maybe the 10th or 11th event which we are conducting, and there is a very lot of cooperation from you regarding these events and all. I'm very thankful to you, sir. Over to you, sir.
Thank you so much, sir. Thanks for cool introduction. Yeah, so it is always pleasure for us working with CIET. It's been like, yeah, you said right, 10 plus years almost. So we have like yeah, a lot of technologies that we have delivered for students. We have enabled them right from 2010-12, I guess. Yeah, so yeah, coming to today's session, so this is part 2. So I welcome all the students over here who have joined for this workshop. So this is the part 2 session which we are doing as part of our GIS platform enablement. So don't think that part 1 we have missed. So is it like continuation to that? No. So we are just seeing part 2, but part 1, part 2, there is no linkage as such. So people who are coming for the first time also can, as a fresh, you can start learning. And part 1, anyways, we can, enable you later on as well. Yeah, so let me introduce myself. As anyway, sir has told. Myself, Yuktesh. I work at ESRI India as a developer relations manager. I take care of developer outreach program here. So we do work a lot with student developers, startup developers, and enterprise developers. So in that front, we enable developers on our product, so-called ArcGIS, which is one of the leading platform in the location analytics space, the spatial analytics and location intelligence space. So we conduct a lot of workshops, meetups, one-on-one sessions, hackathons, whatnot, any interaction to the developer. So we are here. So we conduct a lot of engagements with the developers. So on that front, Kiran sir was highlighting, like in the recent past also we have done quite good number of workshops. So along with me today, I have joined with three of my colleagues, but only one colleague is going to speak. The other two are support for us in chat. So let me introduce my co-speaker, Sarthak Bhatia. So he is a senior software engineer, application data management team. So he is the key speaker for today. So I'll be talking for 10-15 minutes, and then next 1 hour plus will be talking by my colleague Sarthak. And a couple of more colleagues also joined, Shubham Singh and Yashi Agarwal. So these two colleagues will help us in chat support for today. And these are the two colleagues have delivered our first session. So yeah, so without any further delay, let me go ahead and share my screen, and then let me start my presentation. Can someone confirm, sir? Can you please confirm?
Yes, sir. It is visible.
It is visible, right? Yeah. Okay. Okay, so once again, warm welcome to all the students over here and faculty as well. I hear few faculties were also part of this series of workshop. So thank you so much for your time. So this workshop for sure helps you in enabling on your understanding ArcGIS and location services, and specific to Python, we are focusing to, if you're a Python lover, so what max you can able to do in ArcGIS, you will be learning today. So you can see myself, Yuktesh, and my colleague Sarthak, we are the two speakers for today, and majorly Sarthak will be handling. So moving on, the session is on ArcGIS platform, as I have already told you. So you will be understanding what exactly ArcGIS platform is. So let me talk on agenda. So first I will be talking on about ESRI India. So for the people who have already attended first session, it will be like first 10-15 minutes will be repetitive, because for the new people, for the benefit of new joinees, for the part 2, those who have joined, I have understood more than 50% of the students over here are joining for the first time. So that's the reason. Let me talk a little bit on company, and then followed by importance of location services. And then I'll hand over to my colleague Sarthak. So he'll be talking on use cases specific to location services. He'll introduce what is GIS for us, because most of you are pretty new to GIS. So at a very high level, we'll try to make you understand what is this technology all about. And then the core, the topic for the session is like ArcGIS API for Python. So what all you can able to leverage in regards to Python in ArcGIS platform, and specific use cases on Python along with some demos. And at last, we'll wrap it with, a business plan and some resources we'll use. So anyways, the business plan is not specifically for students like you, but it is always good for you to know about it. Okay, so let me just a second. Yeah. Okay, so let me talk about company. ESRI is a 50-plus-year-old GIS company founded by Mr. Jack Dangermond in 1969 at Redlands, California. So Jack started ESRI with idea that computer-based mapping and analysis could make significant contribution to geographic planning and environmental sciences. That way how Jack started. But today, we are all we are global leader in providing GIS software, that is geographic information system software, location analytics and mapping. So for the various organizations, irrespective of their size and be it any type of industry they are in, so today we are providing, we provide tools to get deeper insights from their geographic and transactional data to improve their day-to-day operational and business results. So if you see on the right bottom, there are some statistics for you to get to know about, how big the company is, right? So we have 100+ offices around the globe. With presence in 130+ countries. We have like 2,500+ partners, having 350K customers worldwide. and 75% of Fortune 500 companies are ESRI customers. And last but not least, 30% of our revenue we spend on R&D. That's where you can understand, how focused we are on, improvising or fine tuning the product on, on a day-to-day basis, right? So, yeah, let's talk. Let me talk a little bit on about ESRI India. So, see, ESRI India is a self-sustained, it's an individual company, self-sustained organization. We formed in the year 1996. So it's been 25 years. Recently, we have completed our 25-year ceremony. So having presence in India with the 25 years, so we have captured 5,000 plus customers across multiple industries like banking, insurance, logistics, e-governance, education. So you can see a whole lot of list over here, right? So our spread is our presence are spread across country, that is like with 14 cities, and offices are in 7 locations. So we are it's a company. It's not a young startup as such. It is we are there in 100 plus countries, so you can imagine, right? So in India, in 7 locations we are, so that's how it is. Let me quickly move on the technology front. Okay, so what do we do, right? So you just now understood what is the company, what is our key product is, and how big it is, right? So what we build ArcGIS. It is leading mapping and spatial analytics software for desktops, SaaS, and enterprise applications, right? So if you see at the bottom, there are a lot of capabilities presented over there, like, starting off with mapping and location enablement, which is everybody can understand by name itself. So field operations, basically for field surveys, we do offer mobile apps with which customers can do field survey. Spatial analytics and data science, we have thousands of tools that helps you in doing spatial analytics, such as network analytics, 3D analytics, watershed analytics are some of the examples. Imagery management and analytics. Let us say we have satellite imagery or aerial photograph. We can do analysis on top of that, right? So real-time visualization analytics. Again, let's say if we are getting a real-time data like feeds or live tracking of a truck, or maybe be it any vehicle, bus, truck, whatever it may be. So if you wanted to see the vision, if you wanted to visualize it, if you wanted to perform some analytics, right, on which route it is traveling at what time, and if you'd like to perform more analytics on top of that, you can do that. So that is called geo analytics. 3D visualization analytics, as I said, like we have third dimension data like elevation away data or height away data, so we can perform analytics on top of that. And so developer tools, so we do also provide some of the developer tools like APIs and SDKs. But anyways, our focus of today's session is talking more on the developer tools only. I leave this to Sarthak to talk more on. Moving on. Yeah, data management and many more. So we provide tools with which you can be able to manage both GIS and non-GIS data. So at a very high level view, I just spoke on the capabilities, but each and every point over here, if you dig in, if you deep dive, there are a lot more stuff for you to learn, right? So moving on. Yeah, so deep integration with leading technologies. So this slide helps in understanding ESRI integrations with the leading companies with leading technologies. If you see in the space of analytics, SAP HANA, IBM Watson, MicroStrategy, in the space of IoT, Cisco, GE Digital, IBM, the content. So we accept content from AccuWeather, Digital Globe, Here Maps, right? So in the space of cloud, so there are big giants. You can see over here AWS, Google Cloud, IBM. So our APIs are available in all these platforms. That's what it meant, right? And coming to data science, which is one of the leading emerging technology space. So Python, R, TensorFlow, these are languages and frameworks where pretty much in popular in the space of data science, right? So we have APIs, we have modules, we have frameworks around it, right? And the developers, when I say developer, all these languages, whatever you can see on the right extreme. So we have, as I said, we have APIs which can support to all these sort of languages. So that's where, so we are pretty much integrated with all these, technologies. Okay, so let me move on. Okay, so now that you have got an idea about ESRI India and its technology presence, Let us try to understand the vision of ArcGIS. So what is the focus? What is the vision of ArcGIS? So vision of ArcGIS is to create a comprehensive platform that supports multiple communities like GIS community, of course, mapping and location services, as well as location analytics and developer communities. So ArcGIS also support geo-enabled systems, which are specialized products that use components of GIS technology for focused workflows like crime analysis, COVID management, disaster management, utility workflows, etc. So you see, I know CIET students take part in Call for Code contest in very great way. So you can pretty much leverage ArcGIS for to input the location services into your applications. So this helps a lot, right? So all of these are available with a SaaS offering, installable software offering, and most recently we have come up with the PaaS offering as well. So that is where our session is focused very much on. So let me move. Yeah, so talking ArcGIS as an open system. So we are not open source, but we are open system. So where the core of ArcGIS ecosystem can be expanded via open data APIs, where there are a number of flexible API like JavaScript, native, Python, etc. So you are going to see Python specific APIs today. So open standards, ArcGIS is maintaining open standards. So your data can come in open format and exported in the same fashion. So it is interoperable, right? So coming to the deployment per se, ArcGIS can be deployed in public and public, private, as well as hybrid architectures. So it comes with cloud offering as well. So for the sake of microservices, we support a mechanism called Docker container technology, and with its container orchestration tool, that is so-called Kubernetes, which is pretty much in popular. ArcGIS supports that as well. Right. So coming to open sciences, ArcGIS supports customizable data science libraries like GeoPandas, R, TensorFlow, PyTorch, etc. So these are all sounding, languages in the space of data science. As I said, ArcGIS pretty much supports these things. So coming to open source. So in ArcGIS platform, you don't only find ESRI location services. We also support open source, services as well. So you'll get to know that in a bit more time. So like open standards, various open source like OSM, GIT, JS leaflets, other OGC compliant standards are supported by ArcGIS pretty much, right? So this may be a little whole of more of terminology for you, but nevertheless you don't have to really bother about all these things. So you being a young developer, what you can able to do in the platform, will learn that, right? Yeah, as I said, so providing developers with powerful mapping and location services. Yeah, so developers like you realize that meaningful maps can bring value to your solutions, right? So we all want best agreed location services and capabilities that can be easily integrated into our apps. So you see, when I say location services, you must be having some sort of doubts. What sort of applications, in which sort of applications we use this? A very simple example, let me highlight, like, restaurant app, Uber, Swiggy, or like, Zomato, to that matter, or, travel apps like Uber, Ola, right? So can you imagine these apps without location intelligence, right? No, right? So this sort of, these are the very basic examples I'm quoting, but Sarthak will help you out with more standard examples. So these sort of apps cannot be able to survive without location. And not only this, most of the apps today, whatever coming out through, be it a mobile app or a web app, like location piece is pretty much important, correct? So tomorrow, whatever the mini project or main project, whatever you are going to build, for that, you should be able to integrate location piece. That is what the whole motto of conducting these sessions. So these sessions will help you out in learning, how to integrate location piece into our project. So you shouldn't be bothered about, like, I don't know GIS. I'm not a GIS background guy, right? So I don't know remote sensing. I don't know spatial, technology. So I'm from computer science background. I'm from IT background. So how can I able to do this? So this sort of questions you may be having, but as I said, so we have platform, we have cool services wherein with the help of API key you could able to easily leverage them and stitch into your application. So that's where we are trying to educate you. So without any further delay, let me proceed. Yeah, I think. Yeah. Okay. So yeah. So data is all around us. Correct. So location info is attached to every data. So what I'm trying to convey is how important, understanding about location is, right? So just to see in the screen here, where are my customers? Where are my outlets? Where is the market for me to expand? So you have budgets, like you have an idea, but you need to also know where are my customers, right? So your focus, let's say your customers are there in Hyderabad, and just for the sake of example I'm taking. But if you are trying to set up your company in, let's say Guntur, okay, so that doesn't help you out, right? So you have to know where are your customers around, correct? So you need to find out the demographics, right? So ultimately location plays vital role in all these areas. So what is the word common in all these sentences over here? If you see, where, right? So solution is what? Location, right? So point is you have to understand the importance of location, and you should learn how to integrate this location into your upcoming building apps, right? So yeah, so what I'll do is I'll pause here, and I'll let my colleague Sarthak to take over, and yeah, so convey on the ArcGIS specific to Python front. How does it helps for us in learning? Yeah, so Sarthak, you are there?
Yes, Yuktesh, sir. Thank you.
Yeah. Over to you, Sarthak.
Right, thank you. I'll be sharing my screen further, and please let me know if my screen is visible. Okay. Is my screen visible right now?
Yes, sir.
Yes.
Yes.
All right. We'll first start with what exactly geographical information systems are, so that we can, start building an idea about what we're going to proceed with further. Now, what everyone needs to understand is that geographical information system is basically a combination of spatial and non-spatial data. Now, almost everybody through their course of engineering and further has worked with non-spatial data, where you have certain attributes that you work with. You may have certain address-based based data for any specific user. Let's say, for instance, we're talking about the Aadhaar card registration. We have all the details of a specific person with respect to their name, their family name, their addresses, their mobile numbers, their locations, zip codes, even blood groups and everything. Let's say we try and link that data specifically with location to identify what kind of national, or rather what kind of a cultural background people have in a specific area, and that we link with respect to locations. Where as soon as we start talking about location, we build a relationship between the spatial and the non-spatial data, and both of these combined give us geographic information systems. Now, geographic information system basically contains multiple different types of maps or data. Now, you may have specific wireframe maps that we're dealing with. You may have terrain maps. You may look at certain digital elevation models or even imageries. Across the course of working through GIS, you will handle all this kind of data. And obviously, we have certain respective non-spatial data also linked along with that. So when we combine all of this non-spatial attribute data along with available imageries and digital elevation models and certain wireframe models and everything, that combined together gives us geographic information systems. Now, as per the agenda today, we had discussed about talking about certain location service use cases. So I will walk you through certain basic use cases wherein location services come in handy. Now, these may or may not be relatable, but in most cases, you can understand as to how and where GIS is applicable to give you a more detailed understanding. So let's look at the case of insurance. Insurance in life with respect to house or vehicles is quite common. It is often required, but the industry, like the insurance industry, faces certain challenges. First of all, is knowing where their customers are positioned, the outreach, so that they can build a respective outreach to their customers. Then finding the proximity to hazards. Let's say there are certain areas where there are higher accidents, so they must accordingly concentrate their vehicle insurances in that area, and accordingly their agents must be placed properly there. Then further, certain respective services must be offered with respect to that location. Then also trying to identify where their policy holders are based, and targeting a proper customer outreach so that they can reach the correct type of customers further. And then trying to identify these certain spatial patterns so that they can actually recover the insurance investments also. So this is a certain problem which is often faced by the insurance industry. And the respective solution that they have for that is they can actually find location-based information about the people in a specific area. Now, this location-based information is basically what we often call as demographic data also. So this demographic data can automatically be generated through ArcGIS itself, and then that can help them drive better understanding and analysis, and then make accordingly informed decisions. So this entire procedure is known as Geo Enrichment of data. Further, we have visualization also, that whatever geo-enriched data is generated, that can actually be utilized to generate maps with dot density to identify which areas can accordingly be identified for, let's say, educational attainment, or further which areas can accordingly be identified for certain colleges placements and everything. So the main point is trying to identify where what requirement of their product is. Let's look at another problem. We have another problem which is a very common problem in today's time, that is the dairy farm problem. Now, dairy farming is basically one of the most growing industries, and milk tends to be collected twice a day, once in the morning, once in the evening. And this milk has to be transported within 2 hours of the milking, so as to maintain the freshness of the milk accordingly. Now, Milk Society cites high operational costs in the milk collection activity, as one of the biggest challenges exacerbated by the roads are not only weather, but also problems that are faced during the rainy season. And such issues faced during transport through long routes, then additional factors such as the time spent, milk collection, capacity of the trucks, and then distribution of the milk from the collection points. All of this basically is a logistic nightmare. And the lack of this proper logistic system contributes to a highly complicated process in proper milk collection and then delivery and distribution also. And then comes up the question of identifying suitable routes, assigning assignment of proper trucks as per those routes, and also proper mapping for the collection points. So what this brings us to is that these dairy farms actually need to go through a lot of data that needs to be processed accordingly. Vehicle routing and then scheduling of milk collection is another issue that is faced. And this situation has only worsened due to the rising cost of fossil fuels, which is again a problem that we're facing, and hence reducing means of transportation. So the solution that they have for dairy farm is basically proper fleet routing, as to how the fleet can be routed in such a way that it becomes highly cost effective. Now, generally, we look at this as the vehicle routing problem. What happens is that in this, the goal of the fleet routing service is to find what orders should be serviced by each vehicle in what sequence, and also what in which sequence those orders should accordingly be catered to. Now, let's say 2 vehicles will depart from a warehouse located in Hyderabad. Each vehicle has a certain capacity, and there are total of 6 farming locations to visit, and it takes them approximately 10 minutes to complete the delivery at each farm. Now, each vehicle in this case needs to return in 2 hours and can only visit maximum 3 farms in total. Main point here is that they have certain limitations to all that needs to be covered. So what they need to identify is the number of stops that have to be identified on the route, then proper route that needs to be assigned with respect to the time and distance, and certain directions for each route that need to be applied. So what this allows us is that each order of that should be serviced accordingly, minimizing transport, taking these factors accordingly, allows proper routing. So taking in the factor of certain locations and then correctly identifying the stops. This helps reduce overall operating costs and then transportation costs also, and hence bring down the difficulties that are being faced by the industry. Another location-based analysis is site suitability analysis. Now, let's say before starting a business, you have to basically identify which location is the most appropriate. For instance, as a user, you're trying to set up a coffee house, and while you're trying to set up your business, you have certain basic requirements. Is that those areas which have the highest number of customers, for example, shopping malls or centers or universities, colleges, markets, government offices. Then another question is which areas actually have or provide higher competition to you. Then comes up the question of transportation of raw materials as well as certain deliveries in case you're operating in all of that. And then the visibility of the place as to how you can gain popularity with respect to the location. Is it visible to a person who's not been to your business before? So this actually comes in under the question of a geocoding service, wherein you can actually find certain addresses, you can find businesses, places around the world. And then knowing where the customers and competitors are can actually help you optimize certain locations as to which areas will help you target the right kind of audience you're looking for. And this process then further helps you identify the correct market allocations as to where you can actually invest in this business. So there are certain location issues that must be tackled accordingly. Now, these are some very basic examples that I've given you as to how and where location services come in handy. Let us go further to tackling about ArcGIS API for Python, what the main agenda for today is. Now, when we're talking about ArcGIS API for Python, what we look at is basically as a developer, you will often come across having to work with REST APIs, which actually give you access to the cloud-based organization itself, wherein all your content, all data, all material that you may have can actually be shared further with your organization and then can actually be utilized as a finished product. But often the issue that is faced is that how you actually access all of this, make sure that all of your data is found in a specific location. Now, as computer science engineers and IT engineers, you must have always heard about cloud technology. Imagine all of that being brought together with the utility of being capable of working on it on the go itself, which means as processing all of that data that you have on the fly so that you can actually generate processed outputs for your end users. So you can actually bring together your content, whatever content your organization has to offer you, and then create further content which is available to the entire community. And that all of that combined with the utilities that Python has to offer with respect to data processing, with respect to analysis, all of that brought together actually helps build the crux of what ArcGIS API for Python is based around. ArcGIS API for Python, it's basically a very powerful library for spatial analysis, for mapping and GIS. It allows you to work with maps and geospatial data, and it is powered by Web GIS, which means that it provides simple and efficient tools for sophisticated vector and raster analysis, for geocoding, or maybe map making, routing, and directions, as well as for organizing and managing your users. Now, in an organization, it is very critical that proper user management is there. There are certain administrators that can actually contain, or rather constrain the usage of the data, make sure proper rights and authorities are provided to everyone, proper access to specific material is provided, proper groups are defined, and restrictions are laid based on access to material. Then we have certain users which are capable of editing the data. You may have certain users who are responsible for updating or publishing data. And then there are certain viewers also. So basically all of this classification, management of this users and certain groups, all of this is also another additional ability which is provided within ArcGIS API for Python. And in addition to working with your own data, which is available within your organization, this library actually enables you to access ready-to-use maps and curated geographic data, which is available from ESRI itself. So that, as well as other authoritative sources, are available and can easily be accessed. So this actually another additional benefit is that it integrates very nicely with certain scientific Python ecosystems. So any one of you who are interested in data science and big data analysis, I will in fact be demonstrating with relation to big data also today. So all of that actually provides a good rich experience for the user itself. And the best part is that all of this can actually be utilized on Jupyter Notebook. So anyone who has worked with Python before has an idea as to what Jupyter Notebook is and how you can actually utilize this. Now, to start with ArcGIS API for Python. Generally, when we talk about Python, we tend to talk about desktop-based programming, wherein you can build certain tools or scripts that operate on the desktop to process any kind of data or any kind of operating system management, anything like that. Now, within ArcGIS itself, we actually have two different products as such and programming domains as such, which can be utilized. For ArcGIS, for desktop particularly, we have the ArcPy suite, which basically works on ArcGIS Pro, that is Python 3.x, and then ArcMap, which is Python 2.x, combined falling under the ArcGIS desktop suite. And then basically related to all kinds of geoprocessing that I've been talking about so far, and also some level of map automation with relation to generating maps and PDFs and everything. Now, but this is all restricted to the desktop. ArcGIS API for Python provides the liberty of actually working against a specific ArcGIS enterprise itself. So you can actually access all the material which is available on the web on the Living Atlas for ArcGIS, on ArcGIS Online and Enterprise. And it is all dependent upon Python 3.x. All kinds of analysis, portal administration, content creation and sharing and stuff like that, as well as big data analysis and data science. All of these are basic properties which fall under the category for ArcGIS API for Python. Now, as I was talking earlier about the different types of users and groups of users that actually can work with ArcGIS API for Python. So we have classified 4 basic working groups. We have the organizational administrators. Now, these are generally the users which basically work with content management, as in with respect to rather organization management, with respect to which user is part of which group, and how a specific user can actually access certain material, which user is restricted to or has restricted access to certain material, or which user has access to the entire range of variety of material. So for people like those. And then we have content publishers, people who are responsible for actually updating the content, for bringing new maps, new data, all of that. And then we have GIS analysts and data scientists who actually work on this data which has been generated by the content publishers. And they further generate further end usage products which can directly be accessed, certain outputs which can be utilized by any industry, as we were just talking about earlier in the location services abilities that we have. And then come in people like us who actually are power users, the developers who actually manage all of this, automate this entire procedure with respect to content management, with respect to organization administration, as well as certain product generation. So there are 4 basic types of groups that work with ArcGIS API for Python. Now, as we discussed earlier, Python is generally revolves, it's basically a part of everything. It is a part of your desktops. It is there in applications with certain databases on the cloud, everything. And that, along with the ability for publishing content which you have available so that it can reach other personnel in your organization, or even beyond to the community, to the developer community entirely. So all of that material through ArcGIS can actually be published on a scalar level so that it is accessible to everyone. And further analysis can also be done on that so that you can actually, generate certain meaningful outputs and certain interactive explorative applications which can be utilized to study the data further, or maybe generate further products accordingly. So this basically falls under the domain of what us developers work around with. And the benefit of working with ArcGIS API for Python is that it allows you to automate Web GIS management, as I was talking about, for certain administrative processes. So you can populate your ArcGIS portal, which falls under the part of an enterprise. For those who may not have an understanding of what exactly ArcGIS Enterprise is, I'll just run through. Is that basically ArcGIS Enterprise in a way works, as the name suggests, across the organization, wherein all your users have access to all the content available within your organization. Now, this content could be any kind of data. It could be imageries, it could be vector data, it could be tabular data, it could even be certain geoprocessing scripts and everything. So all of this material brought together is basically collaborated and kept in one place. And what products are generated out of it, that is the type of content that I'm talking about so far. And when we come down to GIS management, we talk about populating portal with certain users and groups, or maybe cloning entire enterprises so that content from one enterprise can be shared with another enterprise, or reassigning, as I was talking about, reassigning certain users to be able to work on specific set of contents. All of that, and then further perform certain content management, as to search for specific content which may be available within the organization or outside the organization from the wide data pool that ESRI has generated. And then accordingly building certain relationships between different items and data that you, or certain content that you have available. And also generating general progress reports of the users as to respect of what work they've done, what all data they've utilized and everything. So this basically falls under the particulars of managing the content itself. So we will not be looking into this detail for the demonstration today, but we will more be concentrating on content management and then reproducible research. For instance, in content management, we have certain content publishing, wherein you can actually automate the procedure of accessing the data from somewhere else. Let's say you have a specific Wikipedia page wherein you want to actually access a certain specific data which is available, and you want to make that data available within your organization. So this is an open source data that you're accessing, but rather than having to do it all manually and make all of those entries into a tabular data manually, you can actually automate that entire process by first reading that particular HTML table into a pandas data frame, and then further from a pandas data frame converting it to an ArcGIS Enterprise item. That then when we're working with imageries, so updating certain tiles or features from a specific database, or trying to replicate a development environment so that you can move work from your staging environment to a production environment, and then further inspecting and updating certain service links as to certain services. Now, when we talk about REST API, we obviously talk about certain services which are also available for general usage of the users itself. And then we have reproducible research. Now, this is what I was talking about, the final products. Let's say when we start talking about big data and trying to process a larger set of data sets, or utilizing certain third-party Python packages which are available for data science, data analysis and data sciences accordingly, trying to generate certain charts or graphs, or maybe even 2D and 3D maps within Jupyter itself. And then the ability to actually share all of this research further with your peers in the organization and publish it. So ArcGIS API for Python gives you the ability to cover all of this further. Now, the key thing here is that ArcGIS and Jupyter, when we talk about ArcGIS API for Python, so ArcGIS together with Jupyter works very well, as in you can actually access, as you can look in the diagram itself, you can actually access all of your content on a Jupyter notebook itself. And there you can generate the maps, you can generate certain processed outputs, your graphs and representation, and showcase your analysis in a very beautiful and interactive manner. So hence Jupyter is very, very necessary in today's time with respect to when you're working with ArcGIS API for Python. So I'll first take you to the ArcGIS API for, page itself. What you're looking at right now is the ArcGIS API page. We will be sharing the URL for this accordingly. Here, when you access this page, you have the basic introduction documentation available here, where you can actually access all the tutorials which are available for ArcGIS API for Python, and how you can actually apply all of that on Jupyter Notebook. There are multiple guide documentation. I'll be leading you through that also, and certain sample notebooks and detailed API reference for those developers who are interested in building detailed applications and products that can be utilized on this environment itself. Now, the first step, actually, the key step here is actually trying to install the API. So for users who have access to the ArcGIS product and you have access to ArcGIS Pro, you can actually very easily set up a new Python environment. And within that Python environment, you can go further and install the respective libraries which are required. By default, they are actually available also, so they can be accessed accordingly. However, for certain users, wherein the scenario comes up that you do not have access to ArcGIS Pro, you do not have access to the ArcGIS products, then you can actually go further and install directly into our with the minimum dependencies on the Docker itself. So what that does is that you can actually build an independent environment, and within that environment, you can install our API, work with all the functionalities without actually needing to work with ArcGIS Pro itself. So all of that details are available, step-by-step procedure as to how the installations must be done, what steps must be followed. Everything is available, and proper documentation is also available for this on the API page itself. Now, if you go into the guide page, I'll take you through to the basic guide as to how it is supposed to be done and what we're talking about. But before we do that, let's look at what a basic code generally looks like, and what I was trying to talk about all this way. Now, when we're talking about ArcGIS Enterprise, generally, if as a user, you're accessing an ArcGIS online account, you would access your content by logging in. You would log into your ArcGIS online account. You would access all your content which is available within your organization and everything. And what Python allows you to do is it actually allows you to access that same material in that manner. So just a moment. I'll lead you through so that you can actually have a proper understanding of this also. Now, what you're looking at right now is a basic ArcGIS online account that I've logged into. We have certain content available as a specific user. You can actually access all of this content which is available within your organization, and further all the content that may be shared with specific groups that you as a user are part of, and also access to certain data available within the ESRI data pool, which is within the living atlas. So this entire data pool can be accessed using a basic ArcGIS Online or an ArcGIS Enterprise account. And the same thing can be done using ArcGIS API for Python also. So you do not really need to log in here, manually search for all of this. But what you do is you simply first access your GIS. Now, when you try and access your GIS, what you do is you pass the URL there for the specific ArcGIS Online. So let's say I am trying to log into an ArcGIS Online account. I will provide the URL for ArcGIS Online here. And then further, my credentials can be shared. And in case I am not working with an ArcGIS Online account, but rather an enterprise, then using the same function, I can actually access the enterprise details also. And it further gives me the ability to actually search for content. Let's say I have a specific content that I'm searching for, and I want to look for certain restaurants in the Washington DC, or want to build any data related to that. So I can actually fire my query right here, and then restrict it to work with feature layers, restrict the number of outputs accordingly. So all of that can be done, and I have the ability within ArcGIS API for Python to display all of that item in my notebook properly. Now, the reason I'm showcasing all of this is so that when we go into the demos, you can actually understand how all of this is working properly, and how content is actually accessed. The good thing here is that within Jupyter Notebook itself, you can actually visualize all of this data that you've generated and all the layers that you've generated using the simple map widget. So you can automatically generate a map, make it point towards a specific location itself. And then you can add layers also to that specific map to represent the data that you're trying to work with. So the GIS that we're working with here basically is the ArcGIS Online or Enterprise account that we are referencing. And then further, all content accordingly can be accessed. So the key to ArcGIS API for Python is the GIS module, wherein you have certain content that is available. You have certain users, groups, and then specific properties for all of these, as well as the map module. So all of this basically combined together gives you the utility of actually dividing content. So what we've been talking about, let's say we're talking about administration. So as an administrator or a manager, you get to create or certain users. You get to search for content or get properties of certain users accordingly. And then when we're talking about a specific user itself, so you have those certain properties available to you, wherein you can actually update certain roles, update or reassign certain content from a specific user. So it is all correlated. I may have a certain item which I may want to reassign from one user to another. So I can actually correlate this item and then link it to be utilized for the other user. I may have to reassign a user from one group to the other, or maybe share the content of one group to another. So all of this is actually, all of these functionalities can be controlled very easily using the GIS module itself. All of which I have to do manually. I can automate all of these procedures so that I can utilize this process and automate this entirely. I'll take you to the guide first so that you can actually get a better look at it. Now, the guide page that I was talking about, this is going to be your handbook through the entire API itself, wherein you can actually access all the properties of the GIS module that I was talking about, as to what GIS module works around and what the main classes in all of these are. These were the specific classes that I was referring to. so far, and how you can actually access different resources with respect to different content. So everything that we were talking about so far with respect to user management, roles, and groups and content and everything, the same thing in that same way is actually available in the ArcGIS API for Python itself. So you can actually walk through all of this. You can you have the ability of utilizing your GIS functionalities for building new content or accessing pre-generated content, maybe modifying content if required, and all of that material, like step-by-step procedures, examples as to how you can understand the properties of a specific item, and all of that is available within the guidebook itself. So this is a very good set of documentation that you have access to, wherein you can walk through all of this to understand how this API works, and what all functionalities are provided within the API itself. Further, besides the guide, we also have the API reference. Now, the API reference works for those specific developers who are keen on understanding the detailed properties of each module and detailed functions that are available, so that they can build more interactive more interactive products for the end users. So you can actually refer the entire API reference. So each function which is available within each module of this API is available on this page itself. You can go through all of that in detail, how it relates with a certain third-party modules as such, for instance, pandas or matplotlib. All of that is also available, how you actually access content and build content with respect to the server, manage your machines. All of that is available right here. So you can go through this in detail if required. Now, if we have any questions so far, we can maybe take those up, or then we can move into further demonstration also. Or maybe we'll just move directly into the demonstration, and then we'll come back to the questions further. So as I was talking about earlier, the main key thing is that the key to accessing ArcGIS API for Python revolves around having access to Jupyter and then installing the API properly. Once you've done that, you actually have the ability of building multiple Python notebooks that you can work with. And I will be leading you through basic examples that we've built for you, which are also available on the guide page. So let's say as a user who is a part of a specific organization, you are trying to access or the estimated number of civilians who have who possess guns per capita in a country. So you have that data available on a specific public web page, but you need to build that data and bring that data into your own organization so that you can actually make use of that data itself. So that data is available on this table right here. And this is an HTML web page that you have to access. So we will be walking through the process of actually accessing this HTML table, converting it to a pandas data frame, and then further to a portal item. So the step, first of all, is that the key thing is that to run this particular notebook or this sample, you need certain basic libraries in the Conda environment that we were talking about earlier, that you will set up using the Dockers. So you can actually install all of these specific libraries itself further. Once you've installed that, the first step is trying to import the pandas module. Now, when we import the pandas module, it basically, pandas module allows you to work with tabular data, making it very easy and interactive to proceed further. So you pandas actually has the ability to read multiple Excels or HTML tables, anything and everything easily. So you will read that HTML right here. Once you have accessed that, what we have basically given the URL of that HTML and then passed the index of the first table, because that table is accessible within the HTML page itself. And we've converted that to a pandas data frame. Now, a pandas data frame, for those who do not know what a data frame is basically a very similar tabular representation of the data that is available within the Python domain itself. So you can actually build a cell-by-cell frame that contains all the data that is available. Now to access as to what particular data that you've read from that specific URL, what we've done is we've accessed the head, which is the top 5 rows which are available. So that gives us access. If you look at this, what it is giving us are these 5 rows from the top. So we've got these 5 rows. So it will be like 1, 2, 3, and 4, and 5. You can read those using the data frame head. Now we have identified that we have certain not a number and incorrect values which are available. So we can drop those, providing a specific threshold that minimum of like a maximum of 4 not a number values are permitted within a particular column itself. And specific when we're talking about this in place functionality, it means that it will make change to this data frame itself rather than actually generating a new data frame. If I do not keep this property here, then I will have to save this data frame to a specific separate data frame that can be utilized for this. You have the ability to work with either one of those. Then we delete certain columns that are not required. For instance, we do not need this unnamed column or maybe the notes column also to work with. Once we've done that, then we can actually have a look at what our data looks like now. We've removed all the unnecessary values. We've removed the unnecessary columns. We have a much cleaner data. But if you notice within this particular column itself, which is the estimate of civilian firearms, this is not a proper integer. So we need to correct that. So we have the data frame integer location function itself that can actually allow you to clear that. But for a larger data, when we're talking about a very large data, often at times you cannot process that also. So we will have to further estimate the value of that particular column accordingly. Now, but before we do that, what we've done is we basically tried to identify what all object types are there, what the values are for each column specific. So accordingly, this gives us an idea about whether we have numerical or integer. So we can read that all of these have been read as object data types rather than integer or any other specific data type. Now, since we cannot change these entries in the table, when we have a very large table, what we have to do is we have to basically correct the column itself for the numeric format. So we will convert that specific column and we will force it to actually work with those specific values itself in the data frame. So that column is then converted to a numeric value, so that we can further plot it onto a map. Now the moment we start talking about plotting it on a map, the first point is trying to connect to a GIS. So what we've done so far is we've successfully cleaned the data. We've accessed the data. We've converted it from a basic object type to a numeric type. And now what we're supposed to do is next, we're supposed to plot that data on the map. So first of all, we access our GIS, which is our ArcGIS Online. So as I was talking about, when we're trying to access a specific ArcGIS Online account, we provide the URL to arcgis.com. We provide our specific credentials. And then using that, you can access all of this further for representing the data. So you can actually import that content directly onto the what do we say? Import that content onto your enterprise itself. So what we've done is we're importing that data. We had one of the columns, which is basically the leading unique ID column that we're working with, which is the country or the dependent territory that we're working with. So we're reassigning that to a specific value of country code. And once we have that access, this data will automatically be added to our content. And once it is being added to the content, what we do is we simply log in, we try and represent it onto the map. So we know that this data belongs to a specific, we want to represent the data, let's say for a specific area. So let's say we want to represent it for Europe. So we've accordingly given that content, or for UK. So we've given the map to work on that extent. And we've also added the layer where we've added a basic renderer. Now renderers help you actually control the type of symbology which is being utilized. And the field name that needs to be utilized to render this map is accordingly the one that we've provided there. Once we have the map generated, we have all the items that we've accessed. We need to publish this onto our portal further. So in order to publish anything on the portal, we need to understand that first we need to build the properties of that particular item that is being published. So it needs to have a certain title, tags. It may need a snippet or description, and then certain text with respect to what all layers are available, whether there are certain keywords that define this particular data that we have, and what is the main extent of the data. So these are basic metadata that needs to be provided in the form of properties. So accordingly, we've defined those right here, following which we're actually adding all of that content onto our layer itself. So we provided the content there also. And if you notice, we gave it a specific name, which is the worldwide firearms. So after that, using the GIS, I go into the content and search for any item which may have the name worldwide firearms ownership. And automatically it lists out that particular item itself from my enterprise. So this is the process of actually accessing open source data and then utilizing it to build a data frame and then converting it to a portal item finally. Let's look at another example. Now this is more about data analysis. As of now, we were talking about content management. Let's go into more interesting stuff as to data analysis. Now, when we start talking about data analysis, we need to look at as to what data you have available, how you can actually analyze it, or rather what your end utility is, what you're trying to represent that data as. So our concern here is we have the data which shows the locations of multiple tornadoes in the US. We want to identify which areas are the most hit, which have taken the maximum amount of damage. We have all of those attributes available. So while trying to build that, what we do is we access all of that data onto our content itself. So we will first connect with our GIS as we've been doing so far. Once we've connected with our GIS, we will search for that particular content. So we have specific content available. Let's say tornadoes and tracks is the name of the layer that we're looking for, which is available. And we've given the property of outside organization. Now this basic property here allows you to search for content which is available within the ESRI pool. ESRI data pool. So that is living atlas. So any layer which is available on the living atlas can be accessed here itself. We've listed out the output of that search query itself, and that gives us access to this particular item. Once we have access to the item, what we do is we first need to understand what properties are available within that item itself, or what all layers are present within that particular item that we're working with. Since if you notice, it says that it is a feature layer collection, which means that there are multiple layers within this feature layer item that has been obtained. So what we do is we basically access the layers that are available. So we've stored that particular item that was returned. We've stored it in this particular object. And then further, we're iterating through each layer which is available within that particular item to give us the property. So once we have the layers, we basically access the properties, and for the property, we just need the name as of now. So we access the names of all of the layers that are available. And we only want to work with the state population layer and the tornadoes layer. So we will build individual objects for each one of them, which is the boundary and the tornado layer that we've generated here. Now, the next step is to aggregate these points, because we have multiple input points that have been generated. So we need to basically aggregate this data so that we can concise it to work on the specific boundaries that we're working with. So we have actually a summarized data tool, which is the aggregate points available within the API itself. All of the documentation for all of this is available within the API reference page. So it can be seen from there. So, and we're also importing a basic date time module so that you can build a new layer with the current date time to the microsecond level, since we need a specific output name at that time. So we pass the parameters to the aggregate points. The point layer which needs to be aggregated is the tornado layer that we generated earlier. Then the boundary layer is passed as the polygon layer. We make sure that key boundaries with no points. For instance, there are certain boundaries which do not have any points within them. So do you want to still retain them in the output? That we keep as true. And then the output name, which is we've given a standard string text here, along with a dynamic name which is generated from the datetime object that we generated there. So that gives us a specific object, and when we generate that object, you can see that it has generated a new layer by the name of aggregate tornado points, and then the microsecond time itself when it was generated. Now, if we access the properties of this particular, or the layers of this particular item itself, we can represent them on a specific map. So we will add that GIS map. We'll generate a basic map using the map widget itself, and then on that we'll add this aggregate layer. So it is automatically from multiple points which were available here across the states. It is generated an aggregate and given a state-wise classification as to where the maximum amount of tornadoes are. So the larger the circle, that means the larger the number of tornadoes are obtained in that region. But the question comes in is that who has suffered the most? Because a tornado can have multiple devastating effects, including loss of life, property damage, financial losses, and certain things like these. So to identify the populations that have been affected by the tornadoes, we can aggregate the number of tornadoes to the state level and then normalize it with respect to population. So greater the level of population with respect to the number of tornadoes in that area gives us an estimate as to where the highest loss of life or financial losses were. So we've generated a basic map, and there itself, the aggregate layer that we were working with, we've generated a classed color renderer, and we've classified it on the basis of the average population. So we've given it a range, and that average population is being used as a classifier to define which state was the greatest hit accordingly, giving us a specific value. We have the ability of actually adding a legend also onto the map object that we've generated. So accordingly, we can see that legend here along with the distribution across all the states within the US. So that gives us a more insight into what that spatial data looks like. And this actually makes it very easy to, understand what losses have been incurred and where the maximum hit areas were. Now, further feature layers actually can be hosted very easily if they are read into a spatially enabled data frame. So we already have the data available, and we can generate an item from that and then further process that data also. So we directly generate a spatial enabled data frame, which is available within a pandas property itself. So we basically build initially we import pandas. Then we build a spatial data frame from the layer that we have, the aggregate layer itself. So it will not only have all the attributes which are available within that particular layer, but it will also have the shape field, which basically gives us access to those particular location or the geometry that is available within that particular layer itself. Using the SDF shape, this tells us the number of rows per versus the number of columns. So we have total 10 columns and 51 rows. So 51 different states. Each state has an independent entry within this particular layer itself. And to visualize this data, we can actually, show it in a more graphical manner, because we've generated a map that shows which area has the most amount of damages as such. Now we want to represent it in a more graphical manner. So let's say we want to represent which state has the most amount of tornadoes. So we basically sort it first using the point count field, which is available here. That gives us the maximum number of counts. So maximum number of tornadoes in the state, we sort it based on that in the descending order. And then further, using the matplotlib library, we basically plot that onto a map itself. So we can control the properties of that particular graph using the matplotlib library and all its functionalities to represent the final output. So we have the Texas state, which has received close to 8,000 tornadoes. So understanding the data using a graph again becomes easier. So this helps generate a final end product, which is more useful for the user itself. So here we talked about basic aggregation methods that are available. I'll finally showcase a very briefly another one. We were talking about big data analysis. So the key thing is for big data analysis, you need access to an ArcGIS enterprise, which has the extension for Geo Analytics server available. This is not an open source property. However, I'm still demonstrating it for a better understanding. We are trying to process New York City taxi data as to where certain pickups are, what the drop-offs are, what the maximum amount of revenue generated for each taxi user is, or a taxi driver is accordingly. So we're first accessing all of that data from which is downloaded from the NYC Taxi and Limousine Commission website. We've generated that data already. We've published it onto our enterprise as an item. So we will log on to our enterprise. We will access that subset itself, like the data that we have. And once we've accessed that, we can actually represent it onto the map itself. So we've first generated a map image, and then we've added a layer which showcases the data that we are working with. So in this, you can see we have all the points visible itself as to where the drop-offs were. Now, further, we need to process the data as to try and understand what all kind of attributes we're working with. So we'll just we fire a small, very small query where we try and access the top 5 attributes itself. We've fired a query to represent the data, wherein the object ID is less than 5, so that we can represent only the first 4 rows. And then accordingly, we're generating a data frame from that output, and we're trying to understand what the data looks like. So we have, let's say, the rate code IDs, the vendor IDs. These are some basic attributes which are available. The drop-off latitude and longitude, or the fare amount, these are the ones that we want to work with. And these may be the column. There are other columns as to the type of payments. So it may be a cash or a card or anything like that, any tips which were provided. Total amount for that particular thing, and then the total distance traveled. So all of this data actually allows us to, or an insight into this data basically allows us to understand what we're working with. But when we're talking about big data, you cannot actually go row by row. For instance, in the previous 2 examples, we were not working with a very large table. We had 200 entries in one, 51 entries in the other. So you can actually go through the data yourself. But when we're talking about big data, we're talking about lakhs of entries at a time. So you need to basically understand the data by extracting a small subset of it. Now, within this, what we do is we basically first need to build a link with the Geo Analytics server itself. So we have this Python API enterprise, which is available for access. All of this is available on our guide page also. So you can access all of this content from there. We first build a link with that. We check whether Geo Analytics is enabled on our enterprise. Once we've done that, we then go into verifying whether the data store is registered. The Geo Analytic data store is registered, accessing it with a specific item ID. Since we've already published this data, so it can accordingly be verified there itself. So we'll leave it as it is here. You can access the item ID when you publish that specific content onto the enterprise. Once that has also been verified, we can now register this big data with file sharing. So we'll register this to this data that we have that we generated to the data store that is available. And this process actually takes some time, but once you've registered, your data store, which is linked to the enterprise, is able to access the entire schema of the available data. So all columns that are there, what the data type of each one of them is actually available within the manifest file. And in case there are specific symbologies also provided to the data which is being represented in the layer, certain time or delimiters have been provided. All of that can actually be accessed in the manifest. Once you've accessed all of that, you've understood the data, you've registered it with the data store. You now need to proceed into proper data aggregation. so that you can actually generate the output. So what we do is we first access the reference data that we've built with. We access that item, once we've done that, we access all the layers that are present within that item itself. So we particularly want to work with this New York City taxi data. We do not need the crime or the air quality or the calls. We want to work with the New York City taxi data. We access that specific layer here itself. And then we use the same aggregates point tool, which we used earlier also. And using that, we basically try and aggregate the data on a specific spatial reference. So the key point here is that aggregation has to be done when we're working with a specific boundary. We need to make sure that we have a specific coordinate system that it can be referenced with correlation to. So accordingly, that needs to be identified. We pass the specific properties which are required. And once we've done that in the specific area that is done, it may take some execution, right? Now, when we're talking about big data, the key point here is that certain data may be corrupted. You cannot correct the data entirely. You cannot perform enough checks. So the good thing here is that all of these functionalities have the ability to skip all of that data. So that particular data is then accordingly skipped. A warning may be given accordingly that certain data has invalid or missing geometries, but broadly a larger part of the data is processed to give you a proper output. So once we have that, we basically generate the aggregated result across the area that we were working with in New York City. And once we've generated that, we can also generate a heat map as to represent proper visualization as to what areas have greater outreach and which areas have a greater pay scale accordingly. So from a very large point data that would not actually be understandable to the common eye, we've actually brought it all down to a very normalized sense, so that users can reference this data and actually understand, or those taxi users can understand that which are the most highest paid areas accordingly. So these were few examples that I led you through and how ArcGIS API for Python in today's time is actually very useful and can further be utilized also to build greater products from the data that is available. On this note, I'd like to hand back to my colleague Yuktesh sir to take you through to the business plan. Yuktesh sir, are you there?
Yeah, I'm there. Let me share my screen.
Please.
Okay, so you guys can see my screen?
Yes, sir.
Okay, so yeah, so heavy content session, very useful for students. So that was very good session, Sarthak. In short span, you have taken us through a lot of content along with specific use cases as such. So we don't have much time. So what I'll do is I'll quickly take you through a few URLs, and then I'll open floor platform for questions. So yeah, so basically a business plan is something like, being a student, you don't need to really get into it. Basically, ArcGIS platform comes up with a lot of free tier services. So this is the link for you to sign up for ArcGIS platform. Most of you have already registered. If not, please try to register. And right side, you can see on each service, some level of cap is there, like 2 million map tiles per month, 20K geocode searches, right? So like this, on every service, there is some, to some extent, it is free. So you can able to, learn and build some basic applications on ArcGIS platform using this free stuff. Wherever you're going for any live production, then you can go for paid model. Yeah, so this is the URL for Python. So you have got to know a lot of things about Python. So developers.arcgis.com/Python. So this helps you to land on a Python page wherein you can find a lot stuff, whatever Sarthak has conveyed, you can go through. Right. Beyond that, open source, if you need to know more about on ESRI stuff, so you can find esri.github.io. So where you can find 500 plus geospatial projects which have been built by ESRI. And yeah, so coming to enablements, trainings, ESRI training. So sir, if you would like to know from our portal, from our website, do we have any training material as such, get into esri.com/training. And here is what you can find: ArcGIS platform fundamentals. At the bottom you can see ArcGIS platform introduction for developers, ArcGIS platform fundamentals. So there are some learning paths. You can register and you can complete this helps. So whatever we have conveyed, beyond that you can learn here on ArcGIS platform. So coming to some communities, some developer communities. So this is what the community is: community.esri.com. So here it is ESRI community page where developers can come, learn, share about their general developer topics or specific ESRI APIs and SDKs. Yeah, so this is our meetup group, ESRI India Developer Meetup Group. So we have close to 700 members in this group. Here is the link: is meetup.com/ESRI-India-developer-meetup-group. So this is the link. Anyways, we'll share all these links with you. So I request all the participants over here to join this group. Just join this group so that you'll get to know a lot of our future event updates, so that accordingly, as per your availability, you can join them. Yeah, so this is our ESRI India LinkedIn page. So again, latest updates on the location intelligence, location technologies, ArcGIS platform, right? So we we keep on post updates here, so that helps for you to get up-to-date knowledge on ArcGIS suite. So yeah, so while you're working, let us say if you have got any questions, right, you're just stuck somewhere. So this is the link where you can come and post your query, and just ensure of tagging ArcGIS handle. So therefore your questions will be getting answered. So GIS Stack Exchange, and same, so Stack Overflow as well. So here as well you can put your questions along with the handle ArcGIS. So automatically, our tech folks can help you out in responding to your questions. Okay, so we are done from our side. So if you would like to know more about ESRI India, you can get on to www.esri.in, or in terms of any questions, queries, workshop 1, workshop 2, ArcGIS for JavaScript, ArcGIS for Python, right? If you have any more questions, you can always write at developer@esri.in, or you can always write to even Kiran sir as well, so that he can help us in transferring, getting that to us, right? So with this, I will pause and I'll hand it over to Kiran sir, and the floor is open for questions. If any, we are more happy to answer.
Thank you, sir. Thank you so much for the wonderful session.
Thank you.
So all the participants, if you have any doubts, you can type in the chat box, or you can raise your hand, so that the resource persons will speak on that.
On this note, I would like to thank my team. So they're pretty much into application, building. So they are into consulting teams. So their time is pretty precious. So on a weekend, spending time close to 2 hours is really thankful. So I thank Sarthak, I thank Yashi and Shubham, so who spent time for us with us today. Yeah, and last but not least, CIET is always pleasure for us to work with. Kiran sir is I've been sir, I hope you have stopped recording, right? So,
yes, sir.
Yeah. So I have been to more than 100 plus engineering colleges. In fact, 150 plus. Especially in Telugu states, I have been to 100 plus, and Pan India, I have been to 150 plus colleges, and I haven't seen any HOD like Kiran sir with generally HODs means doctors and all. They used to be pretty much into classroom and HOD room, but Kiran sir is out of box. So he does a lot of very innovative engagements, innovative stuff for student community. So we are very fortunate to have a relationship with you, sir. Thank you so much.
Thank you so much, sir.
Yeah, so thank you all students for taking out your time, students as well as few faculty those who have joined. So we look forward for your so now actually we have enabled you on JavaScript and Python in ArcGIS specific. So in soon we are going to host some hackathons as such. We are into the discussions. So the moment when we launch them, we'll again get back to you. We request you to take part in such sort of events so that whatever you have learned here you can able to implement there in any of the use cases, right? That should help you in your further career, right? So yeah, so I'm open, so floor is open for questions. We'll be here for another 5 minutes. Yeah, we are more happy to answer any questions if you have. Sir, over to you.
Participants, if you have any doubts, you can please ask.
I think the students must have already exhausted. It is 7:30 crossed.
Yes, sir.
Right. So we'll do one thing. We will share the links and any source codes as such from our side, and yeah, do practice them later on, and any questions all the time you can reach out to us. Stay in touch. So you can always reach out to Kiran sir, as I said, or you can always write to us. We have given our LinkedIn page and meetup page, right? There also you can able to communicate with us. So with this, I think we can wrap the session, sir.
Yes, sir. Thank you so much, sir.
Yeah, thanks a lot. So thank you all students and faculties, and thanks Shubham, Sarthak, and Yashi for your time.
Right. Thank you everyone for this session, and hope everyone has a nice and safe evening and weekend. Thank you so much.
Yeah, thank you.
Thank you, Bhatia sir. Thank you, Yashi ma'am. Thank you, Yuktesh sir.
Yeah, thank you, sir.
Thank you, sir. Thank you.
Thank you all.
All the participants' feedback and attendance link is posted in the chat box. You can fill it.
Sir, we are all leaving, sir.
Yes, sir. Yes, sir. Thank you, sir.
Thank you so much. Yeah.
Thank you.
Thanks. Yeah, team, we can drop.
Daddy, bike algama.
All the participants who have filled the feedback form can leave now. Thank you. You will receive the certificates within the next 3 days.